How do you connect input-output for a robotic kit? Imagine building a robot that can see, hear, and move just like a human. To do that, you need to connect sensors and motors to the robot's brain. This process is called connecting input and output devices. It's like giving your robot senses and muscles so it can interact with its environment. First, you need to know what kind of sensors and actuators you are using. Sensors are the input devices, like ultrasonic sensors that measure distance, infrared sensors for detecting objects, encoders for tracking wheel rotation, or simple buttons. Actuators are the output devices, such as motors that make the robot move, servos for precise positioning, LEDs for signals, or relays to control bigger devices. Next, look at the controller board that comes with your kit. It usually has special ports labeled for input and output. Digital input and output ports send on or off signals, like turning a light on or off. Analog ports handle variable signals, like measuring how far an object is or controlling motor speed. Some controllers let you configure pins to be input or output depending on what you need. Make sure you understand the voltage requirements too. Many controllers operate at 5 volts or 12 volts, but some parts might need a different power supply. Using the wrong voltage can damage your components, so always check the specifications. Powering your components correctly is essential. Connect the power supply to the power input on your controller or motor driver. For motors and servos, you might need a separate power source, like a 12-volt battery or power bank. Connect the positive terminal to the motor driver's power input and the ground to the common ground shared with the controller. This ensures all parts share the same reference point for signals. When wiring sensors, connect their output pins to the controller's input pins. For digital sensors, connect the signal wire to a digital input port. For analog sensors, connect the sensor's output to an analog input pin. Always connect the ground wire of the sensor to the controller's ground to keep signals stable. Use jumper wires or connectors that fit your kit's ports. Be careful to match positive and ground wires correctly to avoid short circuits. For actuators like motors, connect the motor wires to a motor driver or motor shield. The motor driver acts as a switch that turns the motor on or off and controls its speed. Connect the control signals from the controller to the motor driver's input pins. If your motor driver needs its own power, connect it to the power supply separately. For servos, connect the signal wire to a dedicated output pin, the power wire to the 12-volt or 5-volt supply, and the ground wire to the common ground. Some kits use communication interfaces like USB, I to degrees Celsius, or serial universal asynchronous receiver transmitter to connect different parts. These digital connections send commands from the controller to motors or sensors. Follow the kit's instructions carefully when plugging in these cables. Usually, you will connect the communication port on the controller to the corresponding port on the motor or sensor board. Before powering everything up, double-check all your connections. Make sure wires are secure and positive and ground are correctly matched. Use fuses or circuit breakers if your kit recommends them. Once everything is connected, test each input and output separately. For example, run a simple program to turn on a LED or move a motor. This helps confirm your wiring is correct and everything works smoothly. For example, you might connect a distance sensor to an analog input pin on the controller. Then, connect a motor to a motor driver, which is powered by a 12-volt battery. Connect the motor driver's control pins to digital output pins on the controller. Make sure the ground wires from the sensor, motor driver, and controller are all connected together. When you run your code, the robot can sense obstacles and respond by moving or stopping. By following these steps, you make sure your robot's input sensors and output actuators are wired correctly. This setup allows your robot to sense its surroundings and perform actions based on what it detects. Whether you are assembling a robot for learning or building prototypes for a project, understanding how to connect input and output devices is key. It's the foundation that turns your ideas into working machines.